This is it. We're live. Welcome back. We're starting to do those really often now, like every week. Not sure if we will be able to keep up, but welcome. This is our ninth, I think, Zephyr Tech Talk. So welcome if this is the first time that you're joining us. Welcome back if you're a regular. One thing that we typically do is I ask people, and it will take maybe a few moments for everyone to gather, but whether you're joining us from YouTube or LinkedIn, just say hi in the chat. If you feel like it, say a few words about where you're joining us from, maybe. So I'm Benjamin, joining from France. I think I see, looks like it's Bjarki already lining up on the YouTube chat. So hello, Bjarki. Hello, everyone else. Quick announcement, maybe before we just get started. Like I think I just mentioned, starting to try and do those every week, which means that you would be most welcome to submit a session. Like I think I have a link ready for you to. Is this the one? That's not the one. This one. Zephyr-project.org/propose a tech talk. Any idea that you have if you're working on Zephyr as a contributor, as a maintainer, just as a user, maybe you're building products on top of Zephyr, you'd like to share more about what you've been up to, you'll be most welcome to join me for a future episode. I think we're looking at February for the next sessions. And don't forget, to subscribe to the YouTube channel, the LinkedIn page. That's also a really good way for you to stay in touch, like hit the bell, whatever, just to make sure that you don't miss any upcoming sessions. With that, today's topic is going to be all about security. So it's going to be, I hear it's going to be tons of live demos, tons of tips. Of course, the S in IoT stands for security, right? So there's many reasons why you want to be super careful when it comes to building a connected product. So let's bring our guest for today and let's dive into the topic. Hello, Kasia. How are you doing?
Hi. What I'm doing right now, I am interviewing, but so in general, I work as an embedded developer in security. The company called Sternum is giving the patented runtime protection for IoT devices, and we are also providing a very, very nice observability platform. So these two topics, the security, runtime protection, and the observability, they both are making the devices really secure. I will today I want to show you some types of vulnerabilities. What mistakes can they do in the code, and how general protection can protect against these vulnerabilities, and how we do it in Sternum.
Okay, and can you tell me a bit about yourself, maybe your background? You're a software engineer?
Yes, I am an embedded developer since, I think, 12 years. So I was working with various devices. It was always IoT. It was a washing machine or a thermostat or infotainment in car. All of these devices were, in fact, connected to internet, and that's why they were vulnerable. I was working as embedded developer, and I was not thinking a lot about security, because we have, as embedded developers, we need to have a lot of knowledge about hardware and so on. And in this amount of the requirements for us, I think that developers are not thinking enough about the security, these vulnerabilities.
Right. Yeah. So, and what would you say at the sort of the top, like typical security issues or typical maybe mistakes that developers make when they write embedded and IoT, I guess, applications?
So these embedded devices are usually written in C language or C++, where we have this manual memory management. We have some buffers and so on. So the most typical mistake It's just very simple buffer overflow that can lead to any remote code execution or disclosure of private data or reboots, crashes, undefined behavior, and so on. So it sounds like it's a basics, like just the buffer overflow, but the attacker can do literally everything with such buffer overflow.
Yeah. So yeah, I don't know about our audience, but one thing that I'm super interested in for today's session is trying to understand better. And obviously, and you mentioned that, and this is, I guess, a disclaimer for the audience as well. You're going to show some of the bits that your commercial solutions enable and how they help make IoT solutions hopefully more secure. But one thing that I'm really interested in is how specifically in the context of Zephyr and the context of using tons of open source tools, what is already available out there in terms of like tooling and stuff that can be enabled in like static code analysis, compilers and whatnot to already sort of do the first step of trying to make code more secure and spot potential buffer overflows, etc. And what might be missing, like especially, I guess, at runtime, what are some of the techniques that exist? So I don't know, like, do you want to take it away? I think you have sort of a blog post and like a bunch of tips that you've started to collect. Maybe we can use this as a guide to to see what's out there. And I would love for the audience to also chime in and like some maybe security vulnerabilities that you folks have been exposed to, would love to hear about it and discuss what can be done to address them. So do you want to share? Should I put your screen on the big screen?
Yes. So please share my screen. So I prepared specifically for this webinar the 10 tips that I want to give about the Zephyr security that do not require any commercial tools and so on. I will not bring here up the commercial tools. It's just the things that you can already do, and it's available. So I am sharing my screen. I think you should see the tips. And
yes.
The first tip is just to utilize the TFM, Trusted Firmware Module, if your hardware is allowing for it. This is the, let's say, first thing that we can do for security, just to isolate the resources of the hardware, the kernel, and so on from your application that is considered dangerous. So we assume that the bugs will be in your application first or in a third-party modules that you are using. It's the application part. Even if there is exploitation in this part of code, they will not have easy access to the hardware, to the kernel, and so on. So this is the first tip. Use TFM to isolate the resources. And what also TFM is giving you is the secure boot. The secure boot will ensure that your firmware was not modified between the runs. It's calculating some hash and then ensuring that this firmware is clear. So this is the first tip.
And I guess I should know. Is TFM available on all hardware architectures? Like, is this ARM only, or if I am to use x86 or like Extensa, like would that work too?
I think it's TFM specifically is just for some family of Cortex, but this is the implementation of platform security architecture, and other architectures are having maybe something else. It's not
Similar.
called TFM, but they have something similar.
Okay.
Okay, second tip is use user mode. So in Zephyr, we can downgrade the privilege of the threads, and these threads will operate in some particular memory part, the configured memory for them. So if the exploitation happens in the user mode thread, also, again, it will not have the easy access for other threads or the kernel. So it's, again, just more isolation leads to more security. And it also, it doesn't cost, so why not do it? So let's go to the tip number 3. you can check what types of runtime protection is your hardware offering or the operating system. Because, yes, so in Sternum, we are implementing a very full runtime protection. It will protect against all types of vulnerabilities. And from what I checked on the Zephyr, we have some partial runtime protection. I will show it later in the demo, but I saw the stack protection only there. So you can enable it. There is also hardware stack protection that if your hardware is having, you can also enable hardware protection. Maybe if you have on different operating system, you can have different runtime protection. Sometimes compilers are able to add some additional runtime protection and so on. So you always need to investigate what is available for you and use it. And the tip number 4 is relating to the previous one. So if you use a Zephyr hardening tool after building your project, you will see the recommendation, what Zephyr is recommending us to have enabled. So
or disabled.
Or disabled, exactly, or disabled. So it will tell you if, for example, you could have hardware stack protection, you could enable it, but you didn't. So it will tell you that you failed this step. But also, like you said, some features, on the other hand, are debug features or experimental features. They may disclose too much information for the user or attacker, and you should disable them. So yes, check your configuration with this hardening tool and apply these suggestions.
Yeah, it's literally just one line that we see, I think, at the top. Like, in addition to building your application, you just use the harden config target, and then you get the nice report. I think many people don't know this tool exists. Like, it might not be perfect. I'm not sure it always reflects. The way it's sort of built under the hood, it might not always reflect. It might not surface all the potential issues, but it surfaces a lot. So why not use it?
Exactly. And the next tip is a generic one. You always should do it no matter what operating system you are using. If you are using any third-party library or the operating system itself can be vulnerable, you should stay up to date with published vulnerabilities. If vulnerability goes public, it means everyone knows about it's there. And if you have this not patched version, it's very easy to attack your software. So it's a work. That's why we suggest for the critical devices using runtime protection, which protects devices also from the zero-day vulnerabilities. But if you don't have it, you have to monitor vulnerabilities, patch often when there is the fix for it. And for example, Zephyr is having these the latest vulnerabilities are under embargo. So I think they go public after 3 months of being disclosed. And at this time, we hope that they will be fixed already.
Yes,
so,
usually
here you see in which version this.
Yes, no. In the majority of the cases, they're fixed by the time they are not under embargo anymore. One thing, and I should maybe prepare the link to put it on screen. One thing that's also available, and so that it's really clear for the audience, if you are building a product based on Zephyr, there is a dedicated mailing list which you can subscribe to, so that those issues that are under embargo, you can hear about them ASAP and get all the details and get them fixed as soon as possible. So please, make sure to subscribe to this list, which I will provide you the link for, the Vulnerability Alert Registry. Let me see. There we go. That's the one. You can definitely Google it as well.
Also, this tip also includes that your software should be able to do some remote firmware updates, because if you already sold the device and you get to know that there is
patching is going to be
vulnerability.
fun.
Exactly. The next tip is very simple. It's just to minimize attack surface, because it's obvious the more code, the biggest chances for vulnerabilities. There is statistics saying that for 10,000 lines of code, there is one vulnerability. So it means that if you manage to exclude one module that is taking 10,000 lines of code, you are getting rid of one vulnerability potentially. So what I like in Zephyr is this kconfig language. It's very handy just to, you can just set some configuration to know, and suddenly this module is excluded. So it's I really like this kconfig here for it. Another tip is with logging, tracing, error messaging, and so on. So when you have some error message or like a crash exception and so on, you print somewhere some info, you give it somewhere. You should never, for example, give the user the stack trace. If you show the stack trace, it's much easier to compromise your software. So this error messaging and so on, it should be as short for you to understand the issue, but not enough for this potential attacker to understand what happened in your code. Also, maybe let's talk about tracing, why we need tracing at all. So tracing, it's this part of observability. So if you sold 10,000 devices or anything, you should be able to still detect these the issues in these devices. You don't have them, but you want to be able to monitor them. Like, for example, maybe there is a bug in software, not even the attack, but there is a bug that first is visible in just one device. If you know about this one device, you can fix the issue before it affects the 1,000 devices. Another example of when this observability is useful is, for example, checking how much battery life is still in your whole fleet. So you can observe that in 3 months you need to replace the batteries and so on. And so, well, I maybe it was off topic to this tip, but I told about the tracing. And so what if I already started talking about tracing? I will tell more about the tracing, because we in Sternum, we are tracing the memory corruptions. I think there is no other solution for it. So when the memory is corrupted in any other place, you will be notified on the cloud. And I will show you this later on the demo, where we will corrupt the memory and seeing exactly the traces for it. Tip number 8, it's just avoiding the dangerous functions. There are some functions that are publicly known to be dangerous. Here I wrote some of these functions. I think they shouldn't be used in a newer software, but maybe there are some legacy softwares that still are using these functions. In general, you should never use any function that is not checking the length. Usually they have the version with length checking, but maybe not always. You should always also do the manual buffer sizes handling and so on. Never trust that this function will do everything for you. And what I wanted to show additionally here is common weakness enumeration, because it's a very good page for education. You can browse the top 25 software weaknesses. Like, okay, this is out of bounds, right? And you have examples of code where this weakness is shown. So yes, I think the developers should be familiar with such things, such weaknesses. weakness is not yet vulnerability. It's just the pattern that can become vulnerability.
And some of those patterns, they can be caught and detected by static code analysis tools, right? Like I think a code checker might have, well, there you go. Okay. Go ahead. Just your tip number 9 then.
Yes. So you said a code checker, and I think, I am not sure now, but I think that code checker was recently integrated for Zephyr in the new release in Zephyr.
Yeah, that's correct. Yeah. It's just like the hardening tool you were showing before. It's the same for code checker. It's basically just one line to run the various analysis. I think some of them use some Clang tools and a bunch of others, and then it generates reports, and you can see how your code base is evolving over time as well. Like if there's are you getting new issues? Are you fixing some? Like you can have reports and trends from one day to the other or one release to the other to see how you're doing. And I think Coverity is another tool that does something similar. And yeah, maybe a few of the ones that you're listing here as well.
Yeah, so I listed Valgrind. It's for dynamic memory issues. And I listed the GCC static analysis. This is the flag analyzer, but honestly, I'm not sure if I can use it in Zephyr. I don't see the kconfig for it, so maybe it's not.
That's a good question. People in the chat who are more familiar with this part of the code base than I am, feel free to chime in. I don't know if it's used.
I didn't find a way to use it with Zephyr, but maybe it can be just general tip if you can. But you said which tools are integrated to Zephyr. So for Zephyr, you can use that ones. And the last tip, it's to obfuscate and encrypt your firmware. Because first, if your software is not open source, then reverse engineering it can make it easier to hack it. If it's open source, I saw some public discussion. They state that open source code is in fact safer because it's reviewed by many eyes and so on. But if it's not open source, then only the attacker, let's say, review it, and he can easily find the place where it can be exploited. And the other thing is encryption of firmware, because there is also a risk of stealing intellectual property. So someone can just take your code and sell it as his own code. So that's it. I think TFM is providing encryption of firmware feature. So that was these tips. And now I want to show this memory issue. So let's call it attack, but it will be not full attack. It will be just example of how attack can be done. I'm setting up my environment. I am copy pasting some prepared sample because for showing Sternum possibilities, I need the network connection. So I have a code that is already connected to the network. I will show you. So this main, it's not doing anything yet except of reading the bytes from the user input, because I would not be able to write it in 10 minutes. I don't like that code, so I prepared it beforehand. And the other part of this code that I have here is this connection to our cloud. But except of this, there is nothing in this sample. So first, let's see if it builds. It should be just hello world.
And as a reminder, people watching us live, or if you're watching the recording, that works too. feel free to ask any questions you may have. Like if you're watching live, it's easier because we get to answer them directly. Otherwise, you can always also post in the comments and we can answer them after the fact. Okay, so this is basically almost just the Zephyr hello world, but you've enabled some kind of cloud agent that's going to do some remote monitoring, right?
Exactly. So I connected to, I think it's not yet really connected, but it will be connected later. So what I want to do is to corrupt some function pointer. Maybe not here. I will write here. So corruption of function pointers is one of common vulnerabilities. It allows for making jump to any place in the memory. We have, in general, there are some types of attacks. I think I have them described somewhere in our documentation. Let's see. It should show some illustrations of vulnerabilities that we are protecting. It's slow. Okay, it works. So one type of vulnerability is Stack Overflow, just overflowing over the link register. So when we are entering the function, the link register is storing the place where we should go back after going out of this function. But if stack is overflowed in this function, we can override this link register and make a jump to any place. Whatever we put to this place, to this address, we will jump to this because it will be treated as link register. So this is one type of stack overflow. But what I want to do is to stack overflow, but that will not exceed the full stack. It will just overflow the buffer on stack and override some function pointer. And we will see what we can do with such pointer. Okay, so this is these are some two easy functions. We will first want to find pointer to point to hello, but then I will override it in this way that we will jump to this attack, and we will see how Zephyr protections are protecting against this type of attack. I need to put some buffer on the struct because I want to ensure that the buffer will be just above the function pointer in the memory. If I don't put it on the struct, the Zephyr can lay out this memory differently. But remember, the attackers are having already the layout done. They are looking for places that are having such layout where they can have. And also remember that in C++, the virtual table is just a table of pointers to functions. So we will, let's say, mimic such thing. And I will create this function on, how to call it? Okay, I will call it action. And I will take the input from the user, who is me. And I will use this input as the name for this structure, this field. I will write to this structure. My object will be on the stack. First, I will initialize it with some valid values. So right now I wrote the name, but with limitation of 6, which is fitting this buffer. And I will also assign some function pointer to the function hello. So right now, when I call object function, it will just say hello. So let's check it. The function is called action. So I'm doing action, and let's see what it will do. And just a check. I will first do it without any Zephyr protection. So these are some Zephyr protection flags, but let's first check it without any of them. I'm compiling. So while it's, oh no, what happened?
I think that's the first time we are having a live demo that's like that live. That's actually pretty cool. Yeah, let's see how this goes. And one question that I will have for sure is, and it maybe the second part of the demo, but this attack code that you wrote, like the one that I guess eventually you want to try and redirect maliciously to, like in real life, like how would an attacker actually load this particular code in the system? Because like right now you are the sort of the author of the software, and it's like you would intentionally include the attack bit, right?
Yes, so like I said, it's just the example. So the vulnerabilities in code, this is a challenge to find a way to put these bytes there. But
Right.
if there is vulnerability, there is a buffer that, for example, reads too much. It depends on the context. It depends from where it takes these bytes. But this is the job of this hacker. He wants to find a way to put these bytes.
Yeah. Yes. Yeah. Yeah. Or they can try to redirect to other places of the existing code, but just to generate weird behavior, I guess. Like, yeah. Okay.
Yes. We need to remember that the input is not just what user writes by hand, but it can be database, it can be file to read, and so on. So there is plenty of possibilities of injecting some bytes. Okay, I just needed to do something because if this function will be unused, the compiler or linker optimization is removing it. So I will call it here from before hello world. You remember it's just for not removing it because I need it in my binary to show. So right now I have this action, I have this function, I read some bytes, and I will paste the input, I will copy the bytes read to this name, and I will exceed it on purpose. So I will write 10 bytes.
Right.
I will help myself with some printfs. I will print the value of overridden memory. So I want to know what I put into this pointer, and let's see what will be the result now. So what I want to know to do this attack is where is this attack function in memory? So I will dump the binary. This is the address of my build, I think. No, this address. I need to.
Should be.
Yes, maybe now. I have this attack at the address. This is the address of my attack function. 3C4. So I will need to I will need to type 3C4. Okay.
So 6 characters and then the address, right?
Yeah, my function to read this stuff is taking 0x00 and so on. 3C4, 3C5. Okay, so this is the array of this address. Yes, I wrote the last two values are 3 and C4. It's here. It's C5 because I need to add 1 to have the temp code address. So +1 comes for temp code. And we see that I executed the attack. And what more, it was not detected by Zephyr without protections. But I want to show something more on this, not protected code. Let's try to jump to any other place in this function. So jumping to the beginning of function, it looks like the legal usage, but if attackers are trying to exploit the code, they can also try to jump to some parts of the various function to glue together these instructions to create some chain of expected instructions for them. So let's see if I can jump, for example, to 3D6. And this is you see here, it will print the third line. So it will just print the third one. And let's emulate it again and see this changed input. It was 3D6. So I need D7. D7. Okay, and you see, I jumped to arbitrary place of this code, and it was still not detected, but you remember I did not use these stack protections. So let's see if it will work with, it will be detected with stack protections. This 45 source runtime is not available on my Docker, and hardware stack protection is also not available because I don't use hardware. So let's compile it again. And let's see if we will see something more interesting. Now we see that some handlers are inserted. Of course, the addresses are changed because some code was inserted. So this function also moved. First, I will jump to the beginning of the function. Okay, so the beginning of the function is still not detected. But I think that they will detect it if I jump to the third line. So if I jump to 4.3f, I think now some detection will work. 4.3f. But now we see some user files. In fact, it's not detection of Zephyr. I just corrupted some memory by this jump. But anyway, even the jumping to the beginning of the function may be this exploitation. I should not be able to override such function pointers. Maybe just I will just tell you why it did not work with these stack canaries. So what stack canary protection that I had enabled, why it didn't work? So let's see again on this picture. So the stack canary that is included to Zephyr protections, this is monitoring the place where the stack for the function is ending. So if I write more than this function should be able to have Then I will override this stack canary placed above this LR place, this link register, the return address, and then it will be detected. But when I am only operating inside the legal stack of this function, I am not corrupting this canary, and these protections are not detecting any corruption. So maybe let's see how Sternum is solving such issue. Our Sternum integration, I am very satisfied with it because it's very easy to integrate to. So to have the integration of Sternum, we just need to copy some files. I have it on site. I am pasting kconfig file. It's just sorting our payconfig Sternum file. I will enable some features in project configuration. And the most important part is overriding the linker, because our protection takes place in the between the after the compilation, but before the linking. I will explain more in a second. And I also need to use this abstract API port. I need this for sending these alerts for cloud. Okay, and I also, for our protection, I will disable all these Zephyr protections. We will have just my protection. And it will take some time during the build, because we are protecting in compilation time. I will clear to be sure. And let's build. I hope I did not use the socket with this. Okay, so I did something wrong. Cannot find source file. It's probably just abstract API port. Yeah.
Yep.
And when I see it works, I will tell you how we are protecting this. So I see that our linker is being set up. Okay, and it's probably working. So let's explain what we are doing and why this protection is such secure. So normally, these flags of Sternum and so on, they are protecting while the source is compiling. So this is the first drawback. If you are including third-party library, there is no way to apply this protection there, because it was already compiled and you are not recompiling. So what we are doing is we are taking the C sources. Normally it's compiled compiler and the object files are created. And then the object files are linked by linker. And they result in some binary file. And where our protection is taking place, it's after the compilation. We are working on object files, which means we are protecting also the build binaries, like the third-party libraries and so on. We are protecting everything. And we are detecting in assembly code the places where the memory corruption can happen. So we know, for example, that dynamic jumps will be like BLX, BX, or something. We know that if you have a function that is referencing the stack, it's giving the risk of overriding the stack. So we are analyzing the assembly code, and that's why our protection works for 0 days. It's protecting everything without being specific. It's, maybe I will show you assembly when it's done. Here is some output that says how much files, function, and so on we protected. So it says we protected more than 300 dynamic jumps, and more than 500 functions that reference the stack and so on. Okay, so I forgot.
What's the impact on the size of the final binary? Like what's
it's
the
not
overhead?
much. So of course it depends, because each binary can have different amount of the protections that we inserted, but usually it's below 5% or even less. In the worst case, I think I saw 7%, but if it doesn't fit, we can always try to turn off some protections to fit into chip, or there are other methods to make more memory. Yeah, because of course this is the limitation. The code size cannot grow too much, and it's not growing too much. Also, the performance should not be impacted too much, and because we are doing a lot of logic in the compilation time, the runtime is not much impacted. It's also, I think it was maximum 3% of performance loss. So what we are doing is we are taking these object files and we are applying the protection on the object files, and we are producing the protected objects. And then our linker is just calling the original linker, which is linking these protected objects instead of original ones. So this whole process is transparent. Okay, it's built, it's ready. So let's see. I need new address. So new address is 2351. 2351. Okay, it will be jump to the beginning of the function. Oh, it's not here. And you see, we detected the jump even though it was the beginning of the function. So it was totally invisible for the stack protection of Zephyr, but we detected it. We know what type of violation it was and where exactly it happened. And you then can go to observability platform. And I will show you this observability platform. Well, it's opening, and let's see if I have the alert. I have. 40 seconds ago, we had security flow violation. And why it's so important to have these alerts? It's because if the attacker attempts to hack the device, he will never succeed from the first time. He needs to investigate, send some first blah blah bytes, then other bytes, and so on. He will try many different things before he succeeded. And
he or she.
Know, oh, right? Yes, sorry. He or she. It may be a woman also. But you can react before they succeed. And you can fix this issue because you know exactly where it was. And so this is 2 layers of protection. One layer is that we just rebooted. Here, after we detect the issue, we reboot, so he or he cannot continue. But at the same time, we are telling you, it's like the alert, like, the security company calls you, someone is around your home. You can go back and react. So it gives like 100 security against these violations that we are protecting. But I also want,
There is a great question actually from Jovan. I think it's in 2 parts, but what would happen if the device is just too constrained or too dumb that you cannot afford having a full connection to the cloud? Like, would there be a way, if you have such restrictions, to maybe push more like maybe limited information and metadata to some kind of edge device, and then the edge device takes care of eventually sending the data to the Sternum
Yes,
cloud
exactly.
for the full observability.
We have that possibility. So this is this exists. Such solution exists. And also, I also want to say that runtime protection is separate from this cloud alerting. So you can also have just runtime protection without observability, but we of course recommend to have both of them. So you can either don't have the cloud information at all, or you can have this relay device that will send eventually to the cloud.
And just this is by no means a trick question, but is there any sort of standard or open standard to describe like the kind of information and metadata you were showing just before? Is there a standard way to describe that so that potentially there might be like no matter what is the observability platform that one may use, there would still be some sort of like common knowledge of how to describe a security related event. Is there such a thing?
I don't know if there is a standard way. I know that there are, I think there are some open source tools for observability in general, but I don't think they will cover the security attacks. So I'm not sure if I understood the question.
Okay, that's fine. That's fine.
Okay. So I was not reading the question of comments because I was focused on my screen. So maybe someone else has some question that I could answer.
I think we're all caught up with the questions, but that's a great reminder for everyone to, like, we have only 7 or 8 minutes left. So if you have any questions, it's now or never, basically. Or like if it's not now, then it will have to be offline in the comments. But yeah, no other questions so far.
Okay, so I may also show you the jump to this third line of the attack. And I will show you the assembly code where are our protections inserted.
And maybe to circle back, actually, I think it was actually a question from Jovan as well, which I didn't necessarily put on the screen at the time, but saying that if someone gets physical access to a device, there might be nothing else to do than to deprovision the device altogether. Like, is this something that could be implemented rather than rebooting if you detect some malicious behavior? Just almost like brick the device, basically, to make sure that the attacker cannot play with it anymore, like at all? Or like wipe the device, like if would that be an option, or would that not be practical maybe?
So I'm not sure. I think it's not provided by our solution. So maybe you can just implement yourself such thing that if you have alerts on the observability on the platform, you see them, maybe you can send some signal back to wipe this device. We are not doing this, but you can possibly do it yourself. Okay, I wanted to. Okay, so maybe I will not jump to this third line. I will just tell you that it will also the same prevented, because if the jump to the beginning of the function is prevented, then the jump to any other place is also prevented. I will show you some how does it look like in the assembly. I will disassemble the whole binary.
And what happens if the attacker tries to mess up specifically with the bits that were added by Sternum? Like, as how Like any thoughts on what would happen if they were trying to work around what's in place?
Well, I think it's not possible. Like we are not adding startup bytes that can be messed up.
Okay.
I think so. Maybe I would need to consult with my boss, but I think it's not possible. Okay, so this is fresh dump, and let's see on these protections that we added. So attack, where is attack? This is our callback when attack is detected. So we are going to some security alert that in fact you can implement yourself. So you may decide you don't want to reboot, or you may reboot. You may do anything in this callback. But I wanted to show this action function. Okay, so we see some protections here in this assembly code. Oh no, it disappeared. So when we are entering the function, you see we are protecting the prolog. It means we are protecting the link register, and the stack, if it's overflowed, it will be detected. We are protecting all operations like memcopy and so on, and we are protecting dynamic jumps. So in this small function, you already see a lot of protections implemented. It's giving 100% security in this function. I can't imagine of anything more being hacked in this function, so it's a lot. And and in these open source tools or in these Zephyr tools, you usually have just stack protection, so it's not enough to be secure.
Right. Okay, great. Let's see. Oh, there was maybe back to the question I was mentioning before, or I was having before. Jovan is saying that there are projects like Open Telemetry that may define some semantic around cloud observability, but yeah, doesn't look like there's anything for embedded systems specifically.
Yes, I know OpenTelemetry, that's true. It has this cloud observability functionality, but not security.
Okay, yeah, makes sense. All right, yeah, I think we are sort of like slowly reaching the end. Was there anything else that you wanted to share? Like, is there what would be the best way for people to try things out? I mean, obviously there's the blog post that's showing
if
lots of
someone
tips,
is
right?
interested, if someone is interested in knowing more about Sternum and so on, you can reach out to me after the webinar, and maybe I will be able to provide some more information.
Okay, yeah, that's great. No, really appreciated the live demo. Everything worked actually, so that's one thing that's not always the case with live demos. Great job on the timing as well. I think that might be the first time we're actually finishing up pretty much on time. Let me see if I have actually the, just making sure that I am showing. Yeah, that's what's coming next Wednesday. As a reminder, same time, same day, next Wednesday, we will be talking about custom keyboards and ZMK, whatever. Really cool to have Pete, the creator and the main brain behind ZMK, to talk about the project, how it's using Zephyr, what it adds on top of Zephyr. So it should be pretty fun. Let's see if we have final questions in the chat. No, we don't, but we have many people saying thank you, and thank you from my side as well. That was really interesting to see new faces as well. I think we had new, I'm seeing new faces in the comments. So yeah, the recording is available for everyone to catch up, and we will be back next week. Thanks again, Kasia, and we will see you on maybe on Discord later. Bye.
Okay, bye.